We're back at AP Review. This is 2015 BC Free Response 6. The Maclaurin series for a function f is given by this thing that you can see in front of you, and converges to f of x for absolute value of x is less than r, where r is called the radius of convergence for the Maclaurin series. Part A, use the ratio test to find r. So it's nice of them. They told you exactly what they wanted, so thanks for the solid math. So the ratio test is the limit as n approaches infinity of a sub n plus 1 over a sub n, all inside that absolute value, right? So I'm going to have to take this thing, this is my a sub nth term, I'm going to have to do the n plus 1th term, so I'm going to get the limit as n approaches infinity of the n plus 1th term is going to be a negative 3 to the n plus 1 minus 1, which will just be n, x to the n plus 1 over an n plus 1, and then that whole thing is going to get divided by the original nth term, which is a negative 3 to the n minus 1, x to the n all over an n, right? And I'm going to clean stuff up. As you start to do these, you start to get better at them, and they're easier to clean up because you've seen them a million times, right? So when I clean them up, everybody in the nth plus 1 term is going to stay on the same floor they were already on because they're on the top, right? So this n plus 1 will stay on the bottom, right? But then when I clean up the other thing, right, the bottom, this whole bottom's going to get flipped. So the n's going to get flipped to the top, right? The negative 3 to the n minus 1 and the x to the n will stay on the bottom. And I kind of ran out of room, but we're going to make it work. Okay, so if I come back over here, right, I'm going to just group things together the way that they would be grouped because it's all multiplication, so I can put stuff where I want. So I'm going to go ahead and put the negative 3 to the n on top of the negative 3 to the n minus 1, right? I'm going to put the n on top of the n plus 1. And I'm going to put the x to the n plus 1 on top of the x to the n, right? So now a bunch of stuff's going to cancel, right? So what you'll notice is that negative 3 to the n is 1 power higher than a negative 3 to the n minus 1. So that's going to net a negative 3 on the top. The negative doesn't actually matter to me because it's inside an absolute value. So essentially this is going to spit out a 3, right? It's going to spit out a negative 3, but because of the absolute value, it's going to become a 3 anyway. So these guys, so I now have the limit as n approaches infinity, right, of these guys are also just going to net an x, right? The top is 1 power bigger. So I'm going to get a 3x, and the only n stuff is going to be an n over an n plus 1. So because I'm approaching infinity, and they have the same degree, I look at their leading coefficients, which are just 1s. So essentially what ends up happening is I just get that the absolute value of 3x is less than 1. Now, because I was told that the radius is written as the absolute value of x is less than r, I'm just going to divide that 3 over, and I'm going to get the absolute value of x is less than 1/3, which totally mirrors the original setup to point out to you that r equals 1/3, and that's my answer to part A, right? So r is 1/3. I wasn't asked to find the interval of convergence, so I don't have to test the endpoints. That's it. They wanted the radius, and I gave it to them. Part B, right? The first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f, express f prime as a rational function for x values inside that radius of convergence. So a couple things are happening here. So first thing, when you derive something, so this is, remember, this was f, right? When you derive a series, you just derive the individual pieces, including the nth term, right? And now they don't ask me for the nth term in this case, they just ask me for the first 4 terms, so that's great. So my f prime of x, right, should be derivative of this guy, which is a 1, right? Derivative of this guy would be minus a 3x, right? Derivative of this guy would be plus a 9x squared. And then I need one more term after this. I don't think they actually bothered to give me that term, so I'm going to have to go ahead and find that one, right? If I were to find, so this was when n was 1, 2, 3. If I plug in n is 4 to find this extra term, right, that's going to be a negative 27 x to the 4th over 4, right? So if I want to find that extra term, I just go ahead and derive, and I get a negative 27 x to the 3rd, right? And that's all I wanted was the first 4 terms, f prime, like, so what are the first 4 terms that could be used to approximate f prime, right? Dot. Now they asked me to write f as a rational function, so that's tricky code. You only know, like, not just you, like anybody doing this stuff, you only know one type of series that you can actually find what it converges to. Technically 2 if you count telescoping, but when you're asked this question, you know that a geometric series, right, so the trick here is that a geometric series converges to a over 1 minus r if r, the absolute value of r is less than 1. So a geometric series converges to a over 1 minus r. That's the only series that you can comfortably find what it converges to with regularity. Again, there are some exceptions when you're talking about telescoping series. But if they're asking you to say that this series is the same as a rational function, that's a hint, hint, wink, wink, nod, nod, yo, this thing is geometric. And if you're not getting this geometric, go back and double check that you did your derivative properly. Because I'm pretty sure that my a is 1, right? That's my first term. And then what I'm multiplying by every single time to get to the next term is a negative 3x. And you can check that. Do I multiply negative 3x times a negative 3x to get to 9x squared? I do. Do I multiply 9x squared by a negative 3x to get to negative 27x cubed? I do. So it turns out that my r, the thing I'm multiplying by, is a negative 3x. That means that f prime of x is a over 1 minus r, which would be a 1 minus a negative 3x, or 1 plus 3x. So boom, there's my f prime written as a rational function, right? Part C, right? The first 4 non-zero terms of the Maclaurin series for e to the x. Oh, that's nice of them. That's a thing we should have memorized. Then use that series to write the third degree Taylor polynomial for g of x equals e to the x times f of x. About 0. Okay, so I'm going to keep my f of x up there because it's going to matter at some point in this problem. All right, so part C, don't skip the easy instructions. The first thing they asked you to do was to write the first 4 non-zero terms of the Maclaurin series for e to the x, right? So that's a 1 plus an x squared over 2 factorial plus an x cubed over 3 factorial. Those are the first 4 terms, right? Now, they then told me that g of x is equal to e to the x times f of x. So this series that goes on forever times this series that goes on forever, right? But they just want me to write the third degree Taylor polynomial. Okay, so g of x is actually this ridiculous series, 1 plus x squared over 2 factorial plus x cubed over 3 factorial, times this whole crazy thing, x minus 3 halves x squared plus 3x cubed, I ran out of space, plus . You get the gist, right? So this whole thing. So if I want to write the third degree Taylor polynomial, what I need to do is FOIL this thing out. But remember that third degree Taylor polynomial means you only want things up to degree 3, okay? So let's walk through this. When I look at this 1, I realize that the 1 has a degree of 0. So if I'm allowed to go up to degree 3, right? So I'm gonna go ahead and call this p sub 3 for my Taylor polynomial. If I'm allowed to distribute this 1, and I'm allowed to go up to the third degree, I'm gonna be allowed to distribute that 1 to all of these up to the cubic. So I'm gonna get that it's this 1 times the x minus the 3 halves x squared plus the 3x cubed, because since this has a degree of 0, I can go all the way up to the cubic and still fall in that p sub 3 guideline. Plus, now I'm gonna add to that, when I go to multiply the x, this x right here, I say, oh, he's already got a 1 degree, which means I can only go up to the squared here. So it's going to be times x and the negative 3 halves, that's a halves, my bad, x squared. I can't use the 3x cubed because if I did an x times the 3x cubed, I'd have an x to the 4th. And remember, p sub 3 means you go up to x cubed. It doesn't mean 3 terms. It means go up to x cubed. Cool, that guy's done. Then I look at this guy. He's an x squared. So he's x squared over 2 factorial. Well, because he's already a squared, I can multiply him by the x, but I can't multiply him by the negative 3 halves x squared, because that would give me an x to the 4th, which is too big, right? And then I look at this x cubed over 3 factorial, and I realize that I can't multiply him by anybody at all. I can't even use him, because the first term is an x, and if I were to distribute him, it would be too much. So that's all I'm able to do. So now, if I clean these guys up, right, I'm going to go ahead and clean up my stuff. I wrote it in sort of a discombobulated fashion, but we'll survive. So I'm going to go ahead and clean this up at the top, where I have some room, since this is the last part of this problem. Okay, so it seems to me that my p, let's see, you can see me if I write, there we go. All right. So it seems to me that my p sub 3 of x, if I clean this up, right, I have an x, right? So I have an x, I have a negative 3 halves x squared, and I have a plus 3x cubed. Now notice I'm giving myself some space, right? I'm going to add to that, when I distribute this, I get an x squared, and I get a negative 3 halves x cubed. So I get plus an x squared and a negative 3 halves x cubed, right? And the last one is a plus 1/2 x cubed, right? So it seems to me that if I combine all my like terms, I get that I just have an x at the front, right? This is 2 halves and a negative 3 halves, so that should net a negative 1/2 x squared, right? And this is essentially 3.5 minus 1.5, right? So that should net a 2x cubed. So that should be my third degree Taylor polynomial. So this is my third degree Taylor polynomial, right? And they didn't ask me to use it, so that's all they wanted. There you go.